Assalamu alaikum wa rahmatullahi wa barakatuhu. Here we are with you with the YouTube channel NazliBashir and Maths. Kindly like, share and subscribe it. We are here with the new topic of integers. Integers are whole number. Integers are whole numbers that can be positive, negative or zero but not a fractional number. Today we will discuss the properties of integers. These are clear property, commutative property, associative property, distributive property, multiplicative inverse property, additive inverse property, and identity property. Firstly, we will discuss the clear property. Clear property we will discuss firstly with respect to addition, then with respect to subtraction, then with respect to multiplication, and then we will prove that clear property with respect to division is not verified. Okay, firstly come to clear property with respect to addition. This we will explain through examples that clear property with respect to addition will hold. It states that if x and y are any two integers, then their sum, that is x plus y, and their difference, that is x minus y, will also be an integer. That is, it states that sum or difference of any two integers will always be an integer. We will explain it through the example. That is, first we take the example of any two integers, that is plus 9 and plus 2. We are going to add these because here we are explaining clear property with respect to addition. So we will firstly add both of these two. Here we may see that 9 and 2, both of these two belongs to the set of integers, and integers is denoted by, yes, it is denoted by capital Z. Now when we add both of these two, it becomes 9 plus 2, because plus and plus sign, when they will multiply, it will remain plus. Now 9 and 2, both of these two are with which sign? Yes, they are with plus and plus. Both of these two are with plus sign. We know that if the sign is same, we will add them. If the sign is same, we will add them. And with the answer, the same sign we will keep. So 9 plus 2, when we add both of these two, the answer is plus 11. And plus 11, we know that it also belongs to C. It means that if we add two numbers, their sum also belongs to the set of integers. Let's take another example. So another example, in the next example, we will take again the two integers, one with plus and one with minus sign. So here you may see that 3 and minus 5, both of these two belongs to Z, that is set of integers. Now when we add both of these two, we know that plus and minus sign, when they will multiply, it becomes minus. Plus and minus sign will multiply and will become minus. So now 3 and minus 5, both of these two are with different sign. 3 is with plus sign, 5 is with minus sign. So if they have different sign, we will subtract them. If they have different sign, we will subtract them. Now 3 minus 5 will be equal to minus 2, and the sign of greater number will be put with the answer. What is the sign of greater number? Yes, the greater number here is 5 and 5 is with minus sign. So with the answer, minus sign will be put. And the answer which we have got minus 2, it also belongs to set of integers. Come to the next property, clear property with respect to subtraction. Here it states that if x and y are any two integers, then their sum and difference will also be an integer. Take an example. For example, if we have two integers minus 7 and plus 2, we know that minus 7 and plus 2, both of these two belongs to the set of integers. when we subtract both of these, you know that here there is minus and it is plus sign. Minus plus will multiply and will become minus. Now, which type of signs both of these two integers have? Yes, they have same sign. If they have same sign, we will add them. If they have same sign, we will add them. And the sign of greater number, that is the same sign, will be put with the answer. So when we solve both of these two, that is when we add both of these two, it becomes minus 9. And minus 9 also belongs to the set of integers. That is, minus sign also belongs to the set of integers. Thus we have, if we subtract the two integers, the answer is also the number belongs to the set of integers. Let's take another example. Here we will take the two integers minus 3 and minus 5. We will subtract both of these two. Now both of these two are integers? Yes. Now minus and minus, when they will multiply, it becomes plus. That is, minus minus will become plus. Now when we, both of these two are with which sign? Which type of signs they have? Yes, minus 3 has minus sign. 5 has plus sign. That is, they have different sign. They have different signs. So we will subtract them. Then we will subtract them. And with the answer, the sign of largest number will be written. What is the largest number here? Yes, it is plus 5. So with the answer, we will write plus 2. Again, plus 2 belongs to the set of integers. Plus 2 belongs to the set of integers. It means if we subtract the two integers, the answer also belongs to the set of integers. So we will say that Clay property with respect to subtraction will hold in the set of integers. Next, we are going to prove Clay property with respect to multiplication with the help of examples. Here we will prove that if x and y are any two integers, then their product, that is xy, will also be an integer. So take an example of two integers, that is plus 9 and plus 2. Both of these two are, yes, they are integers. Now we have to multiply both of these two. What are their signs? They are with plus, plus, that is, both of these two are with plus sign. When we multiply both of these two, the answer will also be written with the plus sign. So what is their answer? When we find their product, 9 2s are 18, and with the answer we will put plus sign. If plus 18 also belongs to Z, yes, it also belongs to Z. It means product of two integers is also an integer. Next, another example is plus 3 multiplied by minus 5. Both of these two, again they have taken the integer. 3 and minus 5 are belongs to the set of integers. But here we know that if the two opposite signs, that is plus and minus, will multiply, the answer is with which sign? Yes, it is with minus sign. So when we find their product, 3 and minus 5 will multiply. The answer is minus 15, which also belongs to the set of integers. Yes, it also belongs to the set of integers. It means if we multiply two integers, the answer also belongs to the set of integers. Hence, Clay property with respect to multiplication is verified. Next, we are going to prove the two integers with division sign in between. Now we are going to divide the two integers. Here you may see that 9 and 2 are integers. Now when we divide both of these two, the answer is 9 by 2. If 9 by 2 belongs to C, no, 9 by 2 doesn't belong to C, because in the integer there are 0 and plus minus 1, plus minus 2, plus minus 3 and so on, but not the numbers in the form of fraction. So take another example of plus 3 divided by minus 5. When we divide both of these two, we have minus 3 over 5, which again doesn't belong to the integer. We have taken two integers, but when we divide it, the the answer doesn't belong to the set of integer. What does it mean? What result we have from here? We have that Clear property under division is not satisfied. Hence, or we may see that Clear property with respect to division is not verified by both of these two examples. Thank you. Kindly share, like and subscribe our channel for more useful and knowledgeable videos. Thank you so much.